Hello students, today we will cover half subtractor, that is also a combinational circuit. Now in half subtractor we have two inputs A and B. A and B both are two present bit inputs, and we will subtract these two bits and we will have two outputs. One is borrow and another one is difference. So as this is a combinational circuit, we know that there are 4 steps of designing a combinational circuit. The step 1 is to have the truth table. Now what is the truth table? That is the relationship between inputs and outputs. Now step 2 is to have the KMAP for each output line. So we need to do the KMAP for each output line. In case of half subtractor, there are two output lines, borrow and difference. So we will do two KMAPs, and the step number 3 is we need to have the output expression for each output line, and step number 4 is we need to draw the circuit, the logic circuit for the half subtractor or for that particular combinational circuit. So when we are doing the logic circuit diagram, then we need to do the logic circuit to have each outputs for that particular combinational circuits. In case of half subtractor, there are two output lines, borrow and difference. So there will be two circuits for having each of the output. In a single circuit, there will be two parts to have each of the outputs. Now see, the first step is to have the truth table. Now what is the truth table? The truth table is relationship between input and output. So in case of half subtractor, as we are just making difference of two present input bits. So there are two inputs A and B, and there are two outputs, difference and borrow. Let us take this B out, that is borrow out. Now what will be the difference and borrow for each of the input combinations? See, when our input combinations are 0, 0, then what will be the difference and borrow? So how to do the subtraction, binary subtraction? See, 0 minus 0, 0 minus 0 is what? We know that 0 minus 0 is, the first one is 0 minus 0. So 0 minus 0 is difference 0 and borrow also 0. So difference 0 and B out 0. Now the next one is 0 minus 1. Actually we are doing subtraction in the manner A minus B. We will subtract B from A. So the next one, next input combination is 0, 1. So we will do 0, 1. 0 minus 1. So what will be the difference and borrow while we are subtracting 1 from 0? Then the borrow will be 1 and difference will be 1. This is covered in our binary subtraction classes. So please go through that video link. We will provide that in the description box. Now see, 0 minus 1 is difference 1, borrow 1. So difference 1, borrow 1, B out 1. Now 1 minus 0. 1 minus 0 is, while we are subtracting 0 from 1, then difference is 1 and borrow is 0. So difference 1, borrow 0. Now the next one is 1 minus 1. So 1 minus 1 is what? 1 minus 1 is difference will be 0 and borrow will be 0. So difference 0, borrow 0. All these three are very easy. 0 minus 0, 1 minus 0, 1 minus 1. The only thing is 0 minus 1. Now in case of 0 minus 1, I am briefly explaining the 0 minus 1. See, 0 minus 1, so we cannot subtract 1 from 0. So what we have to do? We have to do 1 as a borrow from the next higher bit position. So we have taken 1 as a borrow. While this 1 is coming to the lower bit position, its value will be 2. Now 2 minus 1 is 1 and this is 1. This thing in detail is covered in binary subtraction lecture. So please go through that. I will provide that in the description box. Now this is our truth table. Now what is the next step? The next step is having the KMAP from this truth table. Now while we are doing the KMAP, we need to do KMAP for each output lines. So how many output lines are there? In this case, there are 2 output lines. One is D, that is for difference, and another one is B out, that is for borrow. So we will do 2 KMAPs. Now the next step is to have the KMAP. See, the KMAP is what? The KMAP is the karnaughmap. The karnaughmap is nothing but to have the reduced expression for particular output line. Now in this case we will do 2 KMAPs. One is for D, another one is for B out. Now first let us do the KMAP for difference B. Now how many boxes will be there in this KMAP? See, there are 2 input lines A and B. So there will be 4 boxes, as there are 2 input lines. So number of boxes will be 2 to the power of 2. So 4. This is a 2 variable KMAP because there are 2 input lines. So number of boxes will be 4. This is, we are doing the KMAP for difference D. Now we will put one variable in rows and another variable in columns. Let us put the MSB variable A in rows and B in columns. So what will be the representation of each row? The first row will be represented by A bar and the next row will be represented by A. The first column will be B bar, the next column will be B. Now what will be the boxes? 0, 1, 2, 3. This box number is oriented like this as because we have put the MSB in rows. Now see, what are the difference? How to put the difference? This is for 0th box, this is for box number 1 because this is for 0-0 combination. So 0-0 means decimal 0, 0-1 means decimal 1, 1-0 means decimal 2, 1-1 means decimal 3. So this is for 0, input 0, this is for input 1, this is for input combination 2, this is for input combination 3. So while we are putting these values in boxes, this is how we need to put. We need to maintain this orientation. So 0, 1, 1, 0. Now see, in this case, it is not possible to group because there are 2 ones. Again, 2 ones are placed in diagonal orientation. So we know that in KMAP, diagonal ones cannot be grouped. So we cannot group them. So we will put expression for each individual one. Now for this one, what should be the expression? This is A bar B. For this one, what should be the expression? This is A B bar. So what should be the expression for D? For difference, the expression will be equal to A B bar plus A bar B. Now, A B bar plus A bar B, we can write this as A XOR B. So this is A XOR B. So this is the output expression for difference line, for the line difference. Now we need to put the output expression for B out or borrow output line. So let us do that. Let us put this expression here. B equal to, what is our difference? Expression A XOR B. We are writing this because while we will be doing the circuit, logic circuit, then we will need this expression. Now we will put the next borrow out in the KMAP, B out in the KMAP. So while we are putting the B out in the KMAP, see, B out is how many input combinations are there? There are 4 input combinations. 0, 1, 2, 3. So in the same way, like in case of difference, we need to put these values in the KMAP. And while we are putting these values in the KMAP, we need to keep in mind that these values will be put in the KMAP boxes accordingly. So 0th box will have this value, box number 1 will have this value, box number 2 will have this value, and box number 3 will have this value. So let us do the KMAP for difference. Now KMAP for difference is, how many boxes will be there? Again there will be 4 boxes because there are 2 input lines. Number of boxes in a KMAP is always equal to 2 to the power number of input lines. So here there are 2 input lines. So number of boxes will be 2 to the power of 2, that is equal to 4. Now this is the KMAP for B out, right? KMAP for B out. Now again we will put variable A, that is the MSB variable, in rows and variable B in columns. So what will be the first row? That will be A bar, and the second row will be A. This column, the first column is B bar, the second column is B. And what will be the box numbers? 0, 1, 2, 3. Now let us put these values. These values will be, see, box number 0 will have this value, box number 1 will have this value, box number 2 will have this value 0, box number 3 will have this value, that is 0. So there is only one single one. This is the single one. So we need to find out expression for this particular one only. So what will be the expression? The expression is, see, A bar from row and from column, this is B. So A bar B. So what will be the expression, ultimate expression for B out? The ultimate expression is A bar B. Now what is the next step? So we have got 2 expression for 2 individual output lines. One is B out, that is A bar B, and difference is, this is our difference expression. Difference is equal to A XOR B. So what is our next step? So we have already done 3 steps. Step 1 is this one, to have the truth table. See, for designing any combinational circuit, we need to go through 4 steps. Step 1 is this one, that is to have the truth table. Step 2 is to have the KMAP for each individual output line. Step 3 is to have the output expression for each individual output line. So we have got output expression for each individual output lines. There are 2 output lines, difference and B out, and we have got expression for both the output lines. Now what is the final or 4th step? That is to design or to draw the logic circuit for these 2 output lines. Now let us do the logic circuit. The next step is to have the logic circuit. See, Now we will be doing our logic circuit. While we are doing the logic circuit, please keep in your mind that you need to take all the inputs for designing that particular circuit. In this case, how many inputs are there? There are two inputs, A and B. So, input A and input B. These are the two inputs. Now, what is the expression for difference? A XOR B. So, we just need to put a XOR gate and we need to pass these two variable inputs A and B through that XOR gate to have this output line. So, A XOR gate, as there are two inputs, so a two input XOR gate is sufficient for this. So, this is your difference. A XOR B. Now the next one is what? Borrow out. What is borrow out? A naught dot B. That means we are ANDing A naught, A complement and B. So how many gates will be required? There will be two gates required for this expression. One NOT gate to make this A naught, because see, we have taken inputs A. So as we want to have A complement, so we need to pass that A through a NOT gate and B, dot B. So to make this dot product, we need a AND gate that will AND A complement and B. So first a NOT gate. This is a NOT gate. So what we will have? We will have A complement when this A is passed through this NOT gate. See, whenever you are passing a variable across any other variable, please use this jumper. Okay. Now this is A complement. Then dot B. So B, A complement dot B. There will be a AND gate. So this will give you, this is input B. So what will be this output? B out equal to A complement dot B. So this is our logic circuit diagram. We have designed the circuit to have both the outputs. See, I have already told that we need to design the circuit for each individual output line, and that will be depending upon the inputs. So in this case our inputs are A and B, and for two individual output lines, difference and borrow out, we have designed the logic circuit. So this is all for half subtractor, and in the next class we will cover full subtractor. Thank you.